review for our Unit 3 end of unit assessment. Okay, so problem 1, triangle ABC can be taken to triangle A prime, B prime, C prime. Ooh, see, now there's a problem there. Let me see if I can fix this. I'm actually just going to fix it on here because I want to get through with the video so you guys have it. So I'm going to change this to triangle EFG, and that can move to triangle E prime, F prime, and G prime. Okay, so let's see. Triangle EFG can be taken to triangle E prime, F prime, G prime using rigid motions and dilation. Select all equations that are true. So this is our E prime, F prime, G prime triangle, and this is our EFG. Okay, so if we used a rigid motion, like if we did a rotation and then a dilation, right? We want to select all the equations that would be true. So the first one says I'm actually going to put this on a highlighter. So E prime, G prime, that's this line right here, right, over E prime, F prime is equal to EF over EG. So when you look at the proportions, right, if you had, since EG is on the top, right, E prime, G prime is on the top, EG should be on the top here, right, and EF should be on the bottom there. Okay, so even though it looks like those parts would be corresponding, the way they're written as a ratio wouldn't work because it's not matching, the numerators are not matching the corresponding parts correctly. Okay, so it is not answer number 1. Okay, and we're selecting all, so there may be more than one answer as well. Okay, so now we have, let's see if I can erase this. Okay, now we have FE, this line, right, over F prime E prime, okay, is congruent to G prime F prime over GF. So even though the corresponding parts are, they are proportional to each other, but they're not written correctly as a proportion. Okay, in this case, if we look, we have this prime on the bottom here, so the prime should be on the bottom as well on the second ratio. So if this is F prime, E prime, okay, it's not that that's not set up correctly, FE over F prime, E prime. It's that the next one, right, the corresponding parts of the relationship should be in the same relationship. It should be like that, but that's not what we see here. So it is also not number 2. Let's take a look at the selection for 3 and 4. Okay, in this case, we have E prime, F prime. You hear my dog chewing and burying stuff in the background. Right, E prime, F prime over E prime, G prime. I'm going to leave that paper now. Okay, and that's going to be over EF. That's going to be equal to EF over EG. So if we look at this, right, E prime, F prime, right, shares a relationship with E prime, G prime, as does EF shares that same relationship with EG. Okay, and that is true. So the E prime F prime goes together with EF, so that matches up there. And then E prime G prime, right? The primes are all on one side, so that shows a relationship. And then E prime G prime is showing on the same side of the ratio, the denominator as EG. So 3 is correct. Let's see if any of the other ones match up also, or if any of the other ones are correct. So now we have EF, right? Or, sorry, FE. Oh, let me redo that. This is FE, right? And that's over F prime E prime, right? Sorry, my lines are not that straight. And then we have GF, GF, and that is over G prime F prime. Okay, so that shows a proportional relationship, right? We have E, the relationship of E prime F prime, right? And to EF is the same as the relationship, or equal as the relationship, equivalent as the relationship as GF to G prime F prime. And I'm sorry, let me say that again. So the relationship of FE, right, line segment FE, right, to F prime E prime is equal to the relationship of GF to G prime F prime. That is true as well. Okay, we see that the prime statements, right, are on the same parts of the ratio, and we see the corresponding parts on the correct parts of the ratio. Um, so that's allowing us to tell us that the ratio is set up as a proportion. Okay, number 5 says E prime G prime. So that's this line right here, E prime G prime, right, is has a relationship with EG that is equal to the relationship of E prime F prime, or E prime F prime's relationship to EF. Okay, that is also true. Okay, um, so we see the primes are both on the top, right? The corresponding parts. E prime G prime has a relationship to EG, right? And then we have our equal sign, and then we have what would be, they wouldn't be the corresponding parts, but like exactly, but it would show the corresponding relationship, or it would be an equivalent relationship, right, of two other corresponding parts, E prime, F prime, EF. Okay, so it's really important that line segments or the correct things are being said in the correct spots of the ratio, right? Showing a relationship that's true, right? So, and that's our solution 3, 4, and 5. Okay, so let's take a look at problem 2. Okay, if line BC is parallel to, we're trying to see, is line BC parallel to DE? And we're going to choose the best justification. Now I want to pull out this theorem, right? If a line divides two sides of a triangle proportionately, the line must be parallel to the third side of the triangle. Okay, this is a theorem. Now, in order to prove that these lines are parallel, we have to show that the triangle is divided proportionately, right? So let's take a look at this. Okay, so we want to see that, and I'm just going to pick any proportion here of 9 over 5 is equal to 4 over 2, right? 9 times 2 is 18. 5 times 4 is 20. These are not equal, right? These proportions are not equal. Therefore, these lines, BC, line segments, DE, they are not parallel. Okay, so let's find one that says they're not parallel. Line BC is parallel to DE, so that's not going to be the answer. Line BC is not parallel to DE. That could be the answer. Let me see if there's any other ones that say they're not parallel. So line BC is parallel to line DE because triangle, nope, because we know it's not parallel. Line BC is parallel, nope, we know it's not parallel. So it has to be two, okay? So, and I'm just going to read it all. BC is not parallel to line DE because there is no dilation that sends triangle ADE to triangle ABC. And that's true. There's no dilation. There's no proportional relationship, right? These triangles are not similar. Okay, so let's move on to number 3. Okay, triangle ABC is similar to EFD. What scale factor is required to dilate triangle ABC so that the image A prime, and I'm going to change this. Yeah, no, I'm not going to change it. A prime, B prime, C prime is congruent to triangle EFD. Okay, so we need to find the scale factor. We know that they're similar triangles, right? That's the only way looking at this that we're going to be able to see that they're similar triangles, and so they're going to have a proportional relationship because similar triangles have a proportional relationship. So we have ED, right, is proportional to AC, okay, and BC is proportional to EF. So we have 5 over 3, okay, is proportional to, even if it's x over 2, right, 5 over 3 is going to be our scale factor. Oh no, I'm so wrong. Not 5 over 3. Why is it not 5 over 3? Well, for one thing, our scale factor is getting smaller. So it definitely can't be 5 over 3. It definitely can't be 3. It could be 1/5 or 3/5. And because we know we're working with fractions and proportions, I'm going to say it's 3/5. Okay, sorry. But that it definitely could have been 5 over 3 because of just the simple fact that we see that the triangle is getting smaller. So we know that we have to use a fraction. And 5 over 3, although it's written in fraction form, it's an improper fraction. So it means it is greater than 1. And that's not the case here. We are making the triangle smaller, so it's not greater than 1. Okay, problem 4. Find the length of DF or state what additional information you need to find it. The solution is there, but I'm going to go over it anyway. Um, so we see that these are similar triangles, right? Triangle equals 180. I'm not even going to figure out the other angle. We just know if there's two angles that are equal, the third angle has to be equal as well. So we have AB equals 8 and DE equals 18. Okay, so we want to find DF. We want to find DF. Okay, and we have AC equals 6. So we have, if we do AB over a DF, no, sorry, let me redo this. I like to do AB over DE, no, over DF. Because I'm looking at these angles and I'm seeing that this is going to correspond to BA, okay? And that's equal to AC. I'm going to keep the same triangle together, right? AC over DE, right? So we'll have 8 over DF equals 6 over 18. Okay, now there's a couple of ways to do this. You can cross multiply and then solve for df, right? But you can also see that 6 over 18 is 1/3. So 8 is 1/3 of 24. So that's going to be 24, right? df is going to be 24. If you want, you can cross multiply and solve for x. I just chose to do it an easier way for me. So yes, it's 24 units. Okay. And there are other ways you could have written the proportion. You could have done, um, you know, as long as you're showing a proportional relationship, you could have done 8 over 6, right? And this corresponds with this line. So this corresponds with this, right? So it's going to be 18, right? And df will leave as x, or we'll just call it df. And then you could clearly see 6 times 3 is 18. So then we do the same thing to the top, and so it's 24. Okay, there's a lot of different ways you could get there as long as you're setting up the proportions to show the correct kind of relationship between the parts. Okay, problem 5, you're going to dilate triangle ABC using center P and scale factor. I picked 5/4, right? You have a different one on your exam. What do the properties of dilation tell you about angle B prime? So what I'm going to do to move this 5/4, right? It's going to get bigger, right? Because that's greater than 1. I'm going to split this into 4. Wow, it's going to be hard. I'm not going to lie. It's going to be hard. 1, 2, nope. So let me split this in half. Okay, so look at how tiny each fourth is. So I have 1, 2, right? 1/4, 2/4, 3/4. Well, 1. Move in half. There's 3. There's 4. There's 5. So I'm going to move A prime here, right? And so that was about a half. It's very hard. No lies, right? And now I'm going to break the next side into 4s as well, right? So the first thing I did to break it into 4s was I actually split it in half. And I'm eyeing everything. So we have 1, 2, 3, 4, 4, 4, 5 4s. This is about where C prime is. Now I'm eyeing everything. Everything is not perfect that I'm doing. I am doing the best that I can with it. You're going to have to do the same with some kind of either a straight edge or ruler that's given to you. I'm cleaning it up a little so you can see, right? This is A prime. Okay, and now this is probably the hardest part, right? This is where that dot is. I'm actually going to draw a line here so I see how to keep going out like that from P, because P is my center. So it is hard. I'm not going to tell you it's not, especially when you're not working with a straight edge. Okay, so half is about there, right? 1/4, 2/4, 3/4, 4/4. I would say 5/4, right? So this is going to be kind of something you end up with. I feel like on your test it is 4/3 or something like that. I don't remember if it's 3/2. So it's very, very similar. I just wanted you to see how I broke up um, into 4s and used that as my scale factor. So for here, right? I had broken up, okay? And I went one, two, three, four, five. And then I broke up here into fours, right? The best that I could. That is not the best way to do fours, but you're going to have a ruler on your exam. And I went one, two, three, four. Um, oops, I went to the wrong dot. That's where it's from this dot. Now I went one, two, three, four, five. Okay. It's not easy, but I knew I was counting by fours and I knew I was moving a scale factor of 5 fours. Okay. So I do end up with a bigger triangle. Okay. And what do the properties of dilation tell you about B prime? Of course, B prime and B are congruent, right? Because the dilations do not change the size of the angles, just the measurements of the sides, right? Problem 6. This is probably the hardest problem. And I left this the same as the one you have on your exam because this is just really, this problem is, um, it's really, I want to say meaty and tough to digest. So Tyler was trying to prove that all rhombuses are similar. He thought if he drew two rhombuses, I can find dilations that will make, that will, sorry, I can find dilations that will take one rhombus exactly onto the other. Then he wrote a proof. All rhombuses are not similar. Which steps in Tyler's proofs have flaws? Explain what is wrong with each step. Have flaws. Okay. Step 1, let A, B, C, D, and W, X, Y, Z be rhombuses. By the definition of rhombus, AB is congruent to BC, which is congruent to CD, which is congruent to um, DA, and WX is congruent to XY, which is congruent to YZ, which is congruent to ZW. Okay, that could be true. 2, if you dilate rhombus A, B, C, D by a scale factor given by WX over AB, side A prime, B prime will have the same length as WX because of how I chose the scale factor. Because all sides of a rhombus are congruent, B prime and C prime will have the same length as WX, and therefore the same length as WY. C prime D prime will have the same length as YZ, and A prime D prime will have the same length as WZ. That means all the corresponding sides of A prime, B prime, C prime, D prime, and WXYZ will have the same length. Yes, that is true if you are using a scale factor that's proportional the way that's set up, now all the corresponding parts are going to have the same lengths. Okay, step 3. If all the sides of the two figures are proportional, then those two figures are similar. So there must be a sequence of transformations to take A, B, C, D onto W, X, Y, Z using a dilation of rigid motions. Okay, just looking at that, I'm seeing if all sides of two figures are proportional, then the two figures are similar. That is not true, right? Um, that is not true. First of all, we know the most important thing about figures being similar is actually their angles, right? And their sides need to be proportionate, but their angles, it has to show that their angles are also congruent. As well, then we know that we have those laws for triangles, but we haven't really discussed the different rules for rhombuses, right? So this is really that proportional relationship we know is true for similar triangles, but also we need to show that they would have congruent angles. So number 3, step 3 is not um, is flawed, right? So we're looking on which steps are flawed. Okay, step 4, if you translate A prime, B prime, C prime, D prime by directed line segment AW so that A prime prime and W will coincide. So if you did have two um, rhombuses, and you want, now we had made them all equal lengths, right? The sides. So now we're going by directed line segment AW. So we're bringing one rhombus. We're bringing that A prime, B prime, C prime, D prime to by directed line segment AW, A prime W, so that A prime prime is going to coincide with W now, right? It's going to land on W. Then this step 5 says rotate A prime prime B prime prime C prime prime D prime prime by angle A prime WX so that B prime prime will coincide with X. Now segments A prime prime B prime prime and WX will coincide. That makes sense to me. And again, if this is not making that much sense to you, I suggest that you can use tracing paper and work with that using transformations and motions, because I'm doing it visually, right? It would I don't have the tracing paper, but I just want to go through these with you. So step 6, if needed, reflect A prime prime B prime prime C prime prime D prime prime over segment WX so that D prime prime and Z are on the same side of WX. Now segment A prime prime D prime prime will coincide with, sorry, A prime prime D prime prime and WZ coincide. So 6 is actually incorrect because the angles of the rhombuses are not necessarily congruent. So their segments, they may not coincide correctly. Um, I thought of it as like, I don't know why it was reflecting, because once it had gotten to the correspondent, like to the coinciding WX, and then you're reflecting with it, it is going to go. There was no need to do that, so I'm not really like, I didn't think there was a need for step 6. But according to the book, it says the angles of the rhombuses are not necessarily congruent, which is true. We don't know. We only know that the sides are, that they told us that the sides were congruent once we use the scale factor. Ah, what just happened? Okay. But we don't know about the angles, so we can't show that they're going to coincide that way. Okay. In step 7, once vertices of the rhombus are lined up, the other vertexes has to line up as well, or else shapes wouldn't be rhombuses. So we have shown we can use rigid motion and dilation to line up any two rhombuses, and therefore all rhombuses are similar. So this is also um, not really correct because we don't know about the vertices lining up. All right, because we don't know if the vertexes are actually congruent. Okay, problem 7, I believe this is our last problem on the review. Um, Here is a rectangle with some right angles inside of it. Which triangles are similar to triangles AD, I mean AED? Okay, I know I'm making a lot of errors when I speak, but also I'm not feeling well, and I'm doing it to make sure that you guys can, I mean, I'm doing the review to make sure you guys have a chance to review. So just be a little patient with my mistakes as I'm speaking. All right, so which triangles are similar to triangle AED? Okay, so this we know is 90 degrees, 90 plus 28, right? I believe, yes, 8. Yes, 11. Okay, so then we have 180 minus 118, right? 6. Okay, so this is 62. Okay, so we know this is 90. This is a parallel line here and here, and this is a transversal. God, I cannot draw. Okay, so this is going to be alternate interior angles, so this is going to be 28. And this is fully 90, and we now know 28 plus 62 is 90, if you didn't know that before. And that's 90, okay, and we know that this is also 90, so that's going to be 28, and this is 90, And this is going to be 62 then, 28, 62, and 90. Okay, so now we have all of our angles, right? So which triangles are similar to AED? Well, you know, we have ABE is similar, right? Um, AED, or we can say it as EBA. Okay, we have DCE, we have EFD. So there's a number of triangles that we could have that are similar. So actually, let's just write them out. So AED, right, is similar to EBA, and it's similar to DCF, and it's similar to EFD. Okay, they're all similar. They all share the same. All their angles are congruent, and they have proportional relationships. Okay, so let's continue and see the length of EF. I'm going to get rid of some of these measurements to clear up some of this. Okay, and I'm going to. So we have the length of EF is 8, and the length of ED is 10. Okay, find the length of FA. So I'm going to use Pythagorean theorem is A squared plus B squared equals C squared. And in this case, we have C squared minus, say A squared equals B squared. Because we have our hypotenuse. So we have 10 squared minus 8 squared equals B squared. Square root of 100 minus 64 equals B. Sorry, I'm talking to my dog. So then we end up with the square root of 36 equals B. B, well, it's the whole line, right? But B equals 6. So we end up with this line being 6 right here. That's 6. Okay. Okay, so now what are we looking for here? Find the length of FA. So we're finding this length right here. So I'm going to erase some of this to have some space. So we're looking for FA. Okay, just so I want to put in some of these degrees again. So this is 28, 28, 62, 90. So I can see my corresponding parts. Okay, so I have EF over AD is equal to AF over EF. So that is, right, 8 over AD, which is 6, equals AF over 8. Okay. So 8 times 8 is 64, which equals, I'm just going to substitute that for x, right? 1 by 6, divide by 6. 6 times 12 is 64. Let me just double check that. Nope, 6 times 12 is not. Jeez, am I doing this correct? Let me see. Let me get a calculator. I'm not doing this math. And don't make fun of me. 8 times 8 divided by 6. Get 10.6, so something is up here. I'm doing something wrong. Let me make sure that I have my proportions correct. Okay. EF over AD is the same as AF over EF. So we have 8 over 6 is equal to x over 8. Yeah, actually I'm going to leave it as 64 over 6 is AF. I'm actually just remembering that that is the solution, that I did do it right. I just went a step further and did the division, but I would just leave it as 64 over 6. And to double check that, I can even do double check that, I can do, no, I'm just going to leave it 64 over 6. I mean, yes, I can do Pythagorean theorem